Welcome students to your favorite channel Pradip sir classes as PSC, and after doing all the numericals you can say that wow, what a concept. So all the numericals are very deepest concept, and this is the numerical king series AC Verma solutions, and this is volume 1 chapter 1 unit and dimension and question number 16 and 17 and Pradip sir classes as PSC. Okay. And if you are in first in that particular class, then go back to the previous one and enjoy the numericals, and then come back again for 16 and 17. And we are just very nearest to the goal. That is, there are two numericals, that is 18 and 19. Then we can complete all the numericals. And if you are first, and you can go back to that one, or you can check the description box, and all the links are given there for the previous numericals one. Okay, so let's continue. So students, first of all, write down the question number 16. So question number 16, and it is AC Verma. Okay. 16, and students, it is let I the current through a conductor and R its resistance. First of all, students, this is based on the derivations of a particular equations from the dimensional analysis. So you have to know all the dimensions related to that. So the dimension of current, that is, it is a fundamental. So current is I, and the dimension of V is given here, and the dimension of V is ml square t minus 3, m l2 and t minus 3 and I minus 1, and the R, the dimension of R, and this is equal to ml square and t minus 3, it is also t minus 3 and t minus 3 and I minus of 2. So all the dimensions are given, and you have to relate that particular relationship between I, V and R, and we all know that what is about Ohm's law. Okay, so you know that this is V equal to IR, so you have to derive that particular equations with the help of dimensional derivations. Okay, so we can write V is proportional to I to the power of A, and V is proportional to R to the power of B, or you can take the variable or exponents as X and Y. So this is equal to proportionality constant, you can take as kappa, or you can take as C or something it may be, then A, I to the power of A and R to the power of B. Okay. So you have to put the dimension, that is in place of V you can write ml square t minus 3 and I minus 1, then kappa and I to the power of A, so this is to the power of A, and R to the power of B, that is R is given here, so m l 2 and t minus 3 and then I minus 2 and whole to the power of B. Okay, so then compare the dimensions. So just erase that particular one, and this is so m l2 and t minus 3 and I minus 1, and then a proportionality constant and I to the power of A, and here minus of 2b, so I to the power of A minus 2b, and m to the power of B, and t to the power of minus 3b. Sorry, L, what is about L? So L to the power of 2b and t to the power of minus 3 and t to the power of minus 3b. And you can check the students, ml square t minus 3 and I minus 1, this kappa I to the power of A minus of 2b and m to the power of B and t to the power of minus 3b. Okay, so you have to compare that one. So a minus 2b and this is equal to -1. Compare current with current, and then B. So B equal to 1, since M equal to the power exponents is 1. So this is 1, and then minus of 3B equal to -3, and you can get B equal to 1. So you can easily calculate the value of A and B from that particular equation. So B equal to 1, therefore A equal to minus of 2 into, in place of B, 1, and this is -1. So yes, it is mistake. So A minus 2 equal to this, or -1 plus of 2, this is equal to 1. So A equal to 1 and B equal to 1. Exactly, this is like that. V equal to K, I to the power 1 and B. So the equation is V equal to a proportionality constant and then IR. So if you take K equal to 1, then V equal to IR. Why we take K equal to 1? This is the demerits of dimensional analysis, that it cannot say about a proportionality constant. Okay, so if you write down that particular equation, K equal to kappa IR, then you can get a full marks of this particular derivations. Okay, or you can write, if you know that K equal to 1, then B equal to IR. Okay, so this is completed, and next student write down the next one, that is 17. That is 17. So question number 17. So question number 17, and it is AC Verma. The frequency of vibration of a string depends on the length, and so it is a new term. It is familiar, I think. Frequency. There is frequency means the number of oscillations completed in 1 second. So this is frequency and depends upon the length L between the nodes. What is node, students? So what is node? Since and these are the two waves. These are the two waves, student. These are the two waves, and you can check that particular one. And if I say which wave possesses more frequency, then you can say that this one, particular this one, because it completed at a particular second. That particular wave completed more vibrations within a specific time. So this is a frequency of that particular wave is greater, and if the two waves superpose, what is superposition? When they overlap with one another or act at a particular region of space. So this is called superposition, and here the amplitude is maximum and here the amplitude is minimum. So this point is called antinode. Antinode, and I can discuss elaborately in the chapter waves. So this is antinode and this is node. So what is about node or what is about antinode? And where the amplitude is minimum, where the amplitude is minimum, then it is called node, and where the vibration is maximum, that is called antinode. Okay, so this node or antinode, that is the length of the node, means we can think this is node and this is node. So this is the length of the node, consecutive node, and this is also the length of this one. If we take, then this is also the length of the node and the length of the node. So somehow it is related with frequency, somehow it is related with frequency. So we can write as a frequency is proportional to L to the power of x. That is, the length of the node is somehow it is related. The exponents may be 1, 2, 3, 4 and so on. So f is proportional to L to the power of x, and we can say next one is, and you can think that if the string is given and mass per unit length, if a string is suppose there's the length of the string is this one, then you can measure the mass of that particular string and divided by length, you can get small m. So frequency somehow related with this one, and this is m to the power of y, and is also depend upon and depend upon, here it is given, the frequency of vibration of a string depends on length between the nodes, the tension, if so it is related somehow with this quantity. So free force means tension force in the string. And most of students, you know that when a rubber band is stretched within the teeth and the particular finger, and you can strike at a particular point, then the vibration takes place. And this is like similar, we can say that the vibration can it may be standing wave formation. So this wave comebacks and overlap with one another, that is superposed, and somehow some at a particular places the vibration is maximum, and some of the particular places the vibration is minimum. So it is called node, and this is called antinode. Okay, so that particular frequency of vibration is proportional to the mass per unit length. So what is the dimension about it? Mass by length. Okay, so mass by length, that is ml minus 1, and frequency force, you know that what is the dimension of force, that is mlt minus 2, and what is about length? Length is length. And frequency, what is frequency? Frequency means 1 by time period, so it is t minus 1. So the dimension of frequency is t minus 1. So this is frequency, that is t minus 1. This is not mass per unit length, so you have to take m by l, and force mlt minus 2, and frequency is t minus 1, and so on. Okay, so let's derive a particular equation, and we just reach the equation, that is you have to just write down f is proportional to m to the power, here it is given m to the power of y, and l to the power of x, and f to the power of z. Then you have to put the different dimensions over here and compare the exponents of LHS and RHS. So F is proportional or equal to a proportionality constant, and mass by length, so ml minus 1 whole to the power of y, and length, this is to the power of x, and force mlt minus 2, and this is whole to the power of z. So it is a kappa, and m to the power of y, and m to the power of z. So mlt minus 2 here, student. So m to the power of y and m to the power of z. So this is y plus z. You know the exponents, rule of the exponents. So m and l to the power of minus y, and this is plus, and this is also z, and then t to the power of minus 2z. So this is frequency, and the t minus 1, here it is m equal to 0 and l equal to 0. Students, where the fundamental physical quantity are not related with a particular physical quantity, then you have to take it is as 0. Okay, then compare y plus z. So y plus z, and this is equal to 0, and minus of y plus x plus z, and this is equal to also 0, and minus of 2z, and this is equal to minus, so z equal to half. Okay, so z is given, and if z is half, then you can place here it is, so y equal to minus half. Okay, so y and z you can calculate it, and from that particular equation you also calculated x, and this is equal to, so y equal to minus half, and the z equal to plus half. So this and this cancel this one, so we can write that somehow it is wrong, I think. So y plus z equal to 0, y plus z equal to 0, and if you put here this is equal to half, and you can get y equal to minus half. So minus, oh yes, it is so x equal to minus of y, minus of minus, that is plus half. So this is equal to minus of minus means half, plus x plus of z means half, and this is equal to 0, so x equal to minus 1. Okay, so x is minus 1, y is minus half, and z is half. So we can put the equation in place of this equation. So f is proportional to, or it is a constant, and m equal to y. So y equal to minus half, and length to the power of x, so x equal to -1, and f equals to z, so z equal to it is half. So you can write kappa in L divided by L, it is -1, so it is in denominator portion, and then root over of we can write f by m, since it is minus, so and root means half to the power of half. So this is the relation, and I think you realize the numericals. And so students, and 16 and 17, so students 16 and 17 are completed, and up to 16 and 17 it is completed, and there are two numericals, there is 18 and 19, and I completed most probably today I completed this one. So wait and for the next class, and last of all I want to say, continue your study. Okay, so thank you.